Luca Congedo and you're watching From QGIS to Remote Sensing. This video tutorial is about the accuracy assessment of a classification, in particular using the new tools of the semi-automatic classification plugin version 6.4. We're going to use the stratified random sampling for selecting random points that will be photo-interpreted, and then we are going to calculate the error of the classification using the unbiased error matrix. So let's zoom in. So the first step is sample design. First we are going to add the classification raster to QGIS, here at the raster, and select the classification, here, open, and add. Here we have the classification raster with 4 classes: water, built-up, vegetation, and bare soil. For sample design we are going to calculate the area proportion of each class. So first open the SCP menu. In the post-processing tools, we select classification report here, click and we open the tool, we click the refresh button here and we select the classification raster. Then we click run. Then we save the classification report, a text file here, and we have here for each class the pixel sum and the class percentage. This is used in this expression where n is the number of samples and we calculate the summation of the difference between the map area proportion of each class and the standard deviation of each class, divided by the expected standard deviation of the overall accuracy, all to the power of 2. Please refer to the text of the tutorial for the details. And after the calculation we have a total of 567 samples that we're going to stratify for each class. In this tutorial we are also dividing by 10 the number of samples for simplifying the process. The next step of the sample collection, we need to open the bandset tool here, for instance from the SCP menu. In the bandset tool we click the refresh button and we select the classification. So we add the classification to the first bandset here. We don't need to change any parameter, we just need this bandset for setting the reference system that will be used for the row creation. We also need to create a new training input here. Click this button. We enter, for instance, sample. Here we have the path of the training input, where each sample will be saved. Now we can open the SCP tool from the basic tool, multiple row creation. Here we have several options, the number of points, the sample. We have also other options inside grid and minimum distance of samples. But the option that we are going to use in this tutorial is this one, stratified for the values, so I'm going to check this. And we enter here the expression that allows us to select raster values. But first we need to set these settings here in the working toolbar, these row settings, for the minimum and maximum area. Because we are going to collect 1 pixel size samples, so we enter here 1 for the minimum area and 1 for the maximum area. This way this table will be automatically filled with 1 in the minimum and 1 for the maximum field. Now we enter the number of points for the first class, 7, and we change the expression, so raster double equal 1, and we click Create Points. And here we have the first list of samples. We can note 1 for the minimum and 1 for maximum fields, according to these settings. Now we can enter the number of samples of the second class, 18. We change the expression accordingly, and we click Create Points. And here the list is updated. Now we enter the number of samples of the third class, 25, and we change the expression. Then we click Create Points. Here we have the list of points. Now for the fourth class, we have 7 samples. We click Create Points. And here we have the total 57 samples with the coordinates that will be saved in the training input. But first we uncheck this option, Calculate Signature, because we don't need the spectral signature of these samples. And now we click Run to start the creation. Here we have the creation of samples. After a while, all the samples will be saved in the training input. Here we can note the type R, which means that only the polygon is created for each ROI. And we can note the macro class ID and class ID is automatically filled with 1. We of course need to change these values, the macro class ID and the class ID, according to photo interpretation. If we double click over any of these samples, we can zoom automatically to the sample. And of course we need to start a photo interpretation, for instance loading OpenStreetMap or other higher resolution data. Here we have, for instance, this sample over an urban area, and we can proceed with the photo interpretation. Of course, we can also load higher resolution images. Here we have a Sentinel-2 image from Copernicus. If we double-click over the first sample, we can see with this false color composite where vegetation appears red, here with this dark area, which is water. So the first sample is water, and we can enter 1 here, it's already 1, which should enter the class. If we zoom over the second sample here, we can see this second sample cover an area of vegetation, which is red with this color composite. So we need to change the macro class ID here, and we can enter the code of the class vegetation, which is 3. We can also set the class ID for reference. So now we proceed with the photo interpretation. For instance, this sample covers a road, an highway. We can also see the OpenStreetMap. So we can enter here the class 2 for built up. And we proceed for the photo interpretation of all the samples. After the photo interpretation of all the samples, we can proceed with the accuracy assessment. Open the SCP menu here, the accuracy tool, the post-processing. Now we need to select the classification to assess, classification, and the reference vector, which is the sample, the training input. We set here macro class ID as vector field of the training input. And then we click Run, and we select where to save the accuracy raster and statistics. After a while, the calculation, we can see here the error raster, the accuracy raster, where each value represents a combination between reference and classification here. And these combinations are listed here in the table, where you can see the error matrix code, the reference code, and the classified code. Then we have the error matrix, where we have the pixel count between classification and reference here. And then we have the very useful area-based error matrix. Please refer to the text of the tutorial for the details, but with this error matrix we have the area proportion, the unbiased area proportion of each class. Here we have the area from the classification, the class proportion, and here we have the unbiased area estimate, where you can see that it is different from the raster classification estimate. And with this area we have also the standard error here. The standard error area and the 95% confidence interval of the area. So this is very useful for estimating the truth area of each class. Then we have the producer accuracy, the user's accuracy, and the other statistics for each class. And of course the overall accuracy and the kappa hat classification. All these are calculated with unbiased error matrix. These statistics are also saved inside this text file here, the accuracy CSV file. We can open it with a spreadsheet. This is a text file separated by tab, so we can use the program to separate the fields here. And we can use all these statistics in other programs to calculate the other statistics. So this was the accuracy assessment of a classification. If you have comments or questions, please join the Facebook group of the Semi-Automatic Classification Committee. Thank you for watching.